Hey guys, and welcome to Graham Campbell's Information Technology series, presenting episode 2 topic, Fundamentals of Hardware and Software Part 2. The things we should learn in this episode: primary storage. So now we're at primary storage, and we're going to learn the types of primary storage. So primary storage inside the CPU is very quick and easy for the computer to use. And there are of two types, RAM and ROM. And these are examples of the RAM and ROM. So RAM. RAM stands for Random Access Memory. The RAM stores the current instructions and data that the computer is using. RAM is read-write memory, which means it can store new data. RAM is volatile, which means if the computer is switched off or the electricity goes off, all data stored in RAM will be lost. Now we're at ROM. ROM stands for read-only memory. ROM stores instructions to start up the computer system. These instructions are fixed in the factory where the computer was built. ROM is read-only, which means the instructions cannot be changed. ROM is non-volatile, so these instructions are not lost when the computer is turned off. So continuing ROM. Nowadays, there are also forms of ROM, which can be altered after they leave the factory. These are known as PROM and EPROM. PROM means programmable read-only memory. PROM is a blank when it leaves the factory, and the instructions are added later by a programmer. But then they are fixed and cannot be changed. EPROM means erasable programmable read-only memory. So if EPROM is exposed to ultraviolet light, it is wiped clean, so it can be reused to store new instructions. So PROM is like what we call would be an example of a CD. We usually buy the CD blank, but some CDs, when you write to it, or when we store on it or use data, it is permanent. It cannot be changed. It cannot be altered. So that would be an example of how PROM operates. While EPROM now is a chip. So from it leaves the factory, it does has instructions on it. And if you want to change that chip altogether, all the programmer would have to do was to take the EPROM from the motherboard where it was on and expose it to ultraviolet light, and it would be wiped clean and can be reused over and over again. However, disadvantage include if you left the computer in the sunlight, you have risk of the EPROM wiping clean, and you have to pay the programmer to write a next program all over again. So key points. Any system that can exist in two distinct forms is called a bistable system. An example of this is a computer. It can be on or off. For example, an electric bulb light can be on or off, so it is bistable. Computer storage devices are bistable, and the information is stored in a form of on and off signals. Binary notation, made of ones and zeros, is used to describe the bistable information. So now we're learning binary data. RAM and ROM store data and instructions in binary form, typically as electronic signals that can be on or off. We can write an on signal as 1 and an off signal as 0. Of course, if you look inside the CPU, you wouldn't see any ones and zeros. This is how we write about it. So bit, a single on or off signal, a single 1 or 0 is called a bit. This is short for binary digit. Binary data continued. So a byte, a group of bits enough to store one letter or other characters, is called a byte. Typically, there are 8 bits in a byte. Storage capacity is measured in bytes. See the table below. So, this is how computer data is measured in. So this is how much it stores roughly an exact value. Byte, 1 character, 8 bits. Kilobyte, 1000 characters, 1024 bytes. Megabyte, 1,000,000 characters, exactly 1048,576 bytes. Exact usage varies. So the value of a megabyte can vary depending on what device you're using. Gigabyte, 1,000,000,000 characters, which is generally 1000 megabytes. And a terabyte, 1,000,000,000,000 characters, or 1000 gigabytes. So word. What is word? The number of bits that can be processed in a single operation within the CPU is known as a word. Larger and more powerful computers have a larger word size, which means they do more processing in each operation. So the number of bits that the computer can process at a time is called the word size, or the number of words it can process at a time. So typically these days, most computer CPU word sizes are 32 or 64 bits. So generally when you see this in the specification of a computer, we see that most computers are either 32 bits or 64 bits, which means that your computer can process 32 bits in one operation, or for a word size. And same thing for 64 bits. 64 bits in an operation, or 8 word size at each operation. And the more bits a computer can handle at a single operation, the more powerful it is. So guys, this is the end of the video. Please like the video if you enjoyed it, and share it for your friends who really need this video. And don't forget to click that subscribe button for more videos like this. Bye.